This section introduces the core question. We'll examine statements about the WhiteKernel function in Sklearn's Gaussian process regression. I'm going to help you evaluate those statements. Let's get started. A Gaussian process is a powerful probabilistic model. Imagine it as a way to describe a function in a probabilistic manner. Instead of giving one single function, I model a whole family of possible functions, and each of them is associated with a probability. That's what this model does. This question asks me to analyze several statements about the WhiteKernel. We'll need to determine which ones accurately describe its behavior. This title highlights that we are working with Gaussian process regression, a method that uses a WhiteKernel to model noise. I'll use my knowledge of Gaussian processes and the WhiteKernel to solve the problem. This phrase refers to the WhiteKernel itself. It's a specific type of kernel function, a core component within Gaussian processes. We are going to examine the properties of this particular kernel. A WhiteKernel adds independent, random noise to a Gaussian process. This means the noise at one point doesn't affect the noise at another point. Think of it like adding a bit of random, static, to the signal. This question asks us to identify true statements about the WhiteKernel in Sklearn's Gaussian process regression. It's a test of our knowledge. I'll explain the concept. A Gaussian process, GP, is a fancy way of describing a collection of random variables, each of which is potentially dependent. We use them to model functions and make predictions. A Gaussian process regression model uses a kernel to determine how similar different outputs will be based on how similar their corresponding inputs are. The WhiteKernel is a special kernel that only adds noise to the model. Think of it like sprinkling salt on food. It adds flavor, variability, but doesn't necessarily change the core flavor. Adding the WhiteKernel increases the model's flexibility, because now it can account for noise in the data. The model fits better because it can explain both the underlying pattern and the randomness in the data. It's like adding another layer to capture more of the details. This question tests your knowledge of the WhiteKernel in Sklearn's Gaussian process regression. I'm assessing your understanding of its properties and how it functions within a Gaussian process model. I want to see if you can correctly identify its key characteristics. Are you ready? I've provided 4 statements about the WhiteKernel. Your task is to determine which statements accurately describe its behavior. I will be evaluating your ability to distinguish fact from fiction regarding this specific kernel. It's a multiple-choice question. Select all that apply. This is the main question you need to answer. I want to assess your understanding of the WhiteKernel's role in Gaussian process regression using Sklearn. I am interested in seeing whether you are aware of its properties and purpose in this machine learning context. Let's see how well you understand this. This statement explores whether you understand that the WhiteKernel's noise level remains the same regardless of the input data. I'm checking to see if you understand its core characteristic of modeling constant variance. This is a key property. This statement tests whether you recognize that the WhiteKernel is primarily for modeling noise, not smooth functions. I'm looking to see if you can differentiate the role of the WhiteKernel from other kernels that model smooth functions. Think carefully about the WhiteKernel's main function. This explores whether you know how to adjust the noise level using the WhiteKernel's hyperparameter. I'm checking if you understand how you can control the amount of noise added using this specific parameter. A crucial aspect of understanding the WhiteKernel is knowing how to control its noise level. This assesses if you understand the impact of adding the WhiteKernel on the flexibility of the Gaussian process model. I'm looking to see if you understand how it affects model performance in scenarios where noise is present in data. This is a bit trickier. Adding white noise can help when the model is too rigid. This quiz question tests your understanding of the WhiteKernel in Sklearn's Gaussian process regression. It's a multiple-choice question designed to assess how well you know the characteristics of the WhiteKernel. Let's dive in. I'll explain this. The WhiteKernel, in simple terms, adds noise to your model. This noise is the same across all input features. It's not higher in one area and lower in another. Think of it as a consistent level of background static. That's what constant variance means. The independent of input features part means the noise level doesn't change depending on where your data points are. This statement is false. The WhiteKernel is all about noise, the opposite of smooth and continuous functions. Smooth functions are like a gentle, rolling hill. The WhiteKernel introduces unpredictable bumps and jumps. It's more like adding static to a radio signal. Yes, the WhiteKernel has one main setting: how much noise to add. This setting is its hyperparameter, and it directly controls the strength or amplitude of that noise. If you increase the hyperparameter, you get more noise, like turning up the volume on the static. That's correct. Imagine you're fitting a line to some data points. If your data is noisy, a simple line won't fit well. Adding the WhiteKernel is like acknowledging that noise. You're adding a noise model to increase the flexibility of your Gaussian process, GP, to accommodate the observed variability. It's a way to make your model more adaptable to messy, real-world data. I see WhiteKernel as a special tool in Gaussian processes. It adds pure, random noise to your model. Think of it like sprinkling salt on a perfectly smooth cake. It adds texture but doesn't change the cake's fundamental shape. It's all about representing randomness without structure. The noise at one point is completely independent of the noise at another point. This is different from other kernels that create smooth, predictable patterns. This is the single setting you get to adjust in the WhiteKernel. It directly dictates how much noise is added. A larger value means more noise, a smaller value means less. It's like controlling the salt shaker. A gentle shake adds a little noise, a vigorous shake adds a lot. It's very intuitive and easy to understand. This statement is true. The hyperparameter of the WhiteKernel directly tunes the amount of noise. It's the control knob. In a Gaussian process, the kernel is the recipe. It dictates how similar nearby points are. It determines if the final result will be smooth and curvy or bumpy and irregular. Each kernel has its own unique properties and abilities. This is the type of quiz question we're dealing with. I will carefully analyze each option provided. This question asks you to identify the true statements about the WhiteKernel, a specific type of kernel used within Sklearn's Gaussian process regression. It's a multiple-choice question, meaning there may be more than one correct answer. This is the topic of discussion, and I am ready to give a deep dive analysis of WhiteKernel. I will explain Gaussian process, GP, in simple terms. Think of it as a way to predict an entire function. Instead of just predicting a single number for one x value, it gives you a whole distribution of possible functions. It gives you a complete sense of uncertainty around your predictions. This uncertainty comes from the model not being completely certain about the pattern in the data. I see this statement as absolutely true. The WhiteKernel in Sklearn has only one hyperparameter, and that one directly sets the level of the noise. Think of it like a volume knob. You turn it up, the noise gets louder. You turn it down, the noise gets quieter. This is also definitely true. Adding a WhiteKernel is like adding a sprinkle of random noise to your Gaussian process model. That extra noise lets the model fit more wiggly data, making it more flexible. I'd say this statement is false. The WhiteKernel is all about noise. It doesn't help model the smooth parts of a function. It's the opposite, it adds roughness. Think of trying to draw a smooth curve while someone keeps shaking your hand. This statement is correct. The noise added by the WhiteKernel is the same everywhere. Its variance, a measure of spread, doesn't change based on where you are in the input space.